Okay, so the next question is integral from 0 to pi of sine squared theta d theta. Now, you guys already wrote down the identities for sine squared. So if you look at the table, sine squared theta can also be written as a half minus a half cos 2 theta. So this is the replacement that you needed to do. So you'll write this 0 to theta of a half minus a half cos 2 theta d theta. You see, it turns into something that we can easily integrate. What is the integral of a half? A half theta. Minus what is the integral of a half cos 2 theta? I will have a half here. Integral of cos is sine. So sine 2 theta over 2. And then the limit is from 0 to pi. Then I can now replace the ranges. So let me first of all write this as a half theta minus a quarter sine 2 theta. Integral is from 0 to pi. So first we replace with pi, then we replace with 0. So I have a half pi minus a quarter sine 2 pi minus, now let's replace with 0. So replacing 0 here, you'll get 0. Sine of 0 is also 0. So this side, we just get 0. So evaluate this. I have a half pi. Sine 2 pi. Pi is 180 degrees. So sine 360 is 0. So this also gives you 0. So your answer is a half pi. That is your answer, a half pi, for those who did it correctly. Okay. Next question is question D. Integral from 0 to 1 of 1 plus x squared. And then we have another squared here and then x dx. You don't have to overthink this question. You can do it actually using substitution, or you can also open this bracket up. When you use substitution, you just say let u be equal to what is inside the bracket. That will be 1 plus x squared. So what is du dx? What is du dx? Du dx, if you differentiate this, you get 0 and then you get 2x. So if you come to rewrite it, 0 to 1 of u squared x, and then what is dx? Makes dx the subject of the formula here. It will be du over 2x. X will go with x. So what you're left with is a half integral from 0 to 1 of u squared du. And this is a half u squared. If you integrate, you get u cubed over 3. Integral is from 0 to 1, but recall u is 1 plus x squared. So this is 1 over 6, u is 1 plus x squared. And then all this is raised to power 3. Integral is from 0 to 1. Yeah, then you replace and get your answer, guys. You replace and get your answer. For those people who went ahead and opened this bracket and multiplied by x, that is also okay. You are getting the same answer eventually. You should have been getting the same answer, all of you. E. Part E. Integral from 4 to 9 of y squared root y dy. Even this one, just write it simply. This is integral from 4 to 9 of y squared. This is root y. So let me write it as y raised to power half dy. Then join this using the laws of indices. So we have y to power 2y a half. That will give me 2 plus a half. So that will be 5 over 2. So y raised to power 5 over 2 dy. Then now integrate. So y raised to power 5 over 2, that will be y raised to power 7 over 2 over 7 over 2. And then the range is from 4 to 9. Then replace the range and get your answer. Any question up until that point? Any question up until that point? Evaluate the definite integral using trapezoidal rule with 4 intervals, giving your answer correct to 3 decimal places. So you have integral from 0 to 1 of 2 over 1 plus x squared dx. You're being told to use 4 intervals. So 4 intervals and you're from 0 to 1. So what will you have? 1 minus 0 over 4. Intervals itakuwa 0.25, 0.25. Meaning, if you come to write your values here, if you come to write your values, if you come to write your values here, let's say you're drawing, you're starting from 0. The next one will be 0.25. The next one will be 0.5. The next one will be 0.75. The next one will be 1. Then if you draw 1, 2, 3, so you have 1, 2, 3, 4. You have your 4 intervals. So what you need to is to get the y values. You need to get this y value. You need to get this y value, this y value, and this y value. How do you go about it? So have your section for x, have your section for y. What is x? So y is equal to the function, which is 2 over 1 plus x squared. When x is 0, y will be what? Put 0 here. You will get y to be 2. When x is 0.25, come and put 0.25 here. You will get your answer. When x is 0.5, come and put 0.5 squared here. You will get your answer. When x is 0.75, come and put your 0.75 there. You will get your answer. Then come and use the which rule? Trapezoidal rule. So you've got to remember what the trapezoidal rule states, guys, because you have it in your books. So you use trapezoidal rules. I've taught you 2 rules. I've taught you the trapezoidal rule and I've taught you the Simpson's rule. So you need to know which is which and how do you go about it. After getting these values, the rest is just to input in your formula. Then question number 4. Question number 4 is also on the rule. Use Simpson's rule with 6 intervals. You're integrating from 0 to pi over 3. The integral of 1 minus a third sine squared theta d theta. Oh, there's a square root. So there's a square root. D theta. Similar to this, just come and put your drawing. You're going to start from 0 and you're going to have 6 intervals. So 6 intervals, pi over 3 minus 0 divided by 6. What are you getting? Pi over 3 divided by 6 is the same as pi over 3 times 1 over 6, which is the same as pi over 18. For those people who decided to convert it into degrees, pia iko sawa tu, no problem. Pi over 3 in terms of degrees is what? Pi is 180 degrees divided by 3. So that translates to 60 degrees. So meaning here you are getting 60 degrees over 6. So what were you getting? 10 degrees. So if you do it in terms of degrees, it will be 10 degrees, 20 degrees, 30 degrees, 40 degrees, 50 degrees, 60 degrees. And clearly those will be 6 intervals. 1, 2, 3, 4, 5, 6. Correct. If you're doing it in terms of pi, it will be pi over 18. Pi over, we are multiplying with 1 over 6 to get, because it was divided by 6. So pi, it's like pi over 18 plus another pi over 18. We have 2 pi over 18. We have 3 pi over 18. We have 4 pi over 18. We have 5 pi over 18. We have 6 pi over 18. Then come get your y values. So x, y. Y is equal to what? Y is the function that you were given. 1 minus a third sine squared theta square root. So for x is equal to 0. We were starting with 0, as you can see, 0. For x is equal to 0 degrees, put your 0 there. It depends. Are you using pi or are you using degrees, so that you know how to put your calculator in radians or in degrees. When x is 0, get your value there using the calculator. When x is 10 degrees or pi over 18, get your value. When x is 20, get your value. When x is 20 degrees, get your value. 30 degrees, get your value, all the way up to 60 degrees. And then input into the Simpson's rule. Simpson's rule is in your book. Guys, for those people who are identifying, when you're using Simpson's rule at a trapezoidal, the first ordinate ni hii ya kwanza, hii ndio y1. Na last one ni hii. Hii ndio yn ya mwisho na hii ndio last one. So when we are talking, this is y1. this is y1, this is y2, this is y3. So when we are, this is y4, y5, y6, y7. So that identify them like this, so that when you come to choosing the even, you know very well, even ni he, na he. Na odd ni y3 na y5, because there are people who are missing out on even and odd. When it came to choosing, you are missing out on it because you are not identifying them from the beginning. Let me know if you guys have a question up until that point. Now, guys, if there's no question, I want to stop there. Question number 5 and 6 I did in class, and also they are in your book. 5 and 6. I did them in class. They are in your books. You have the answers, so you can just go over them. I've finished. So maybe you guys ask a question. If you have a question, you need clarification on anything, please, this is the time to ask, because I'm done going through the 2 cards. Let me know here. Do you have any question? Please, let's not be quiet. It's a yes or no answer. Do you have a question? Let me know. Is it a yes? Is it a no? No. No, no. Okay, guys, then I will end this meeting. If there's no question, I am done. Yes, you never sent the recording of the last part in class. Which part, Naomi? Oh, but it's because I taught it. I'll look for it. It's just somewhere in my laptop. The reason as to why I never sent it, it's because I taught it. But I'll share it when I'll share this recording as well. Because I can see only 23 have joined, and I don't want to repeat this revision. So I'll share it, Naomi. Thank you for the when I get it in my laptop. I'm sure you're talking about trapezoidal. How come for sine squared theta, it can't, okay, fine. No, Ngigi, okay, let me see. Ngigi, or the others. So, as I've said, summary of what we've done and what you need to remember: standard integrals, algebraic substitution, integration by parts, partial integration using partial fractions, integration using trigonometric substitutions. Then under application, look at how to get area under a curve, volume of solids of revolution, arc length, mean, and RMS. Then under numerical integration, numerical integration. Under numerical integration, please recall how to go about trapezoidal rule, and also how to go about Simpson's rule. That is it. That's all you need. How have you agreed?